Good morning, everyone, and thank you for joining us today. My name is Kelly Timko, and I'm with the Business Development Department at Galarath. We have a great turnout today, and in order to make sure that we stay on our schedule, we're going to go ahead and get started. All lines have been placed on mute to avoid background noise, but if you have any questions or if you need any help, you can use the chat or Q&A function on the WebEx to speak with me. We'll also have time for a question and answer session at the conclusion of today's presentation. Today, it's our pleasure to have Lee Fishman, the Senior Director of Development at Galarath, with us. He'll be taking us through today's webinar, Moving Target, How Much Do Mobile Apps Cost to Develop? How much is being spent to create mobile apps and the back-end infrastructure that supports them? To answer this question, we've compiled research from multiple sources with data ranging from the low end of apps to the most sophisticated. So Lee's going to share our research results on this hot topic, and I'm going to go ahead and turn the presentation over to Lee.
Can you hear me?
Yes.
Great. Thank you very much, Kelly. Hello, everyone. I really appreciate your coming. 700,000 apps later and counting. How much do these things cost? It's about time we started answering that question. And the short answer is there is no short answer. I'm going to take you on a bit of an adventure this morning, and for those of you who have not done app development or have not explored the ecosystem, I'm hoping you'll come away as fascinated as I've been going through this. So I'm going to start with the answer. Here's how much apps cost. I went out and looked at, it was really we actually, looked at all the published information on app development cost. And there is actually surprisingly little that is published. And what we found was that apps to be developed can take anywhere from, you can see on the low end of the scale, a day, 30 to 50 hours, a few weeks, not much, and can go to the sky is the limit at Instagram, which is the highest quoted price. Some of these effort hours were converted from price given a prevailing wage of about $125 for a domestic software engineer. Instagram took 5,000 hours. So what accounts for this huge difference? Some of you probably already have a pretty good idea because it's the same story that you see with software generally. There's no one-size-fits-all price for developing software. And just because you're moving to an app doesn't mean that it's a different story. There's no mystery here. If you could see this stacked bar chart, which I've had up, there's a huge number of apps that you can develop very inexpensively, but then there's a huge number that you can't. And we're going to explore a lot of what makes the difference between the low end and the high end, and how the high end is going towards the low end, and maybe some of what you thought might be low end is really high end. If I haven't confused you with that, I'll unconfuse you with the rest. Don't worry. So here we have our famous trio of icons, and you can imagine you're setting out to develop some sort of app, and you've got an idea, and you can do it yourself maybe, or you're going to hire some people. So the first thing you need to ask is, does it sit only on the device? Well, a lot of apps don't. A lot of apps have an API, maybe their own, or maybe they're interfacing. For example, if you're dealing with a Flickr or a Twitter feed, you're going to, and you are Twitter or Flickr, or you're going to have your own API that you've developed that will be communicating with you at some remote URL address, and then you're going to be communicating with that app. Okay, that's a little bit more to do. But then other apps make use of a vast ecosystem of published APIs. There's, according to Programmable Web, which is a repository of APIs, they can't count fast enough, let's put it that way. I think a few weeks ago, they were at 7,000 published APIs that people could access, developers could access, and that number is climbing exponentially. And so many, many, many apps are mashups of multiple services that are being provided via third parties. Some of the major providers, you actually know probably who they are. The number one, if you can guess, who can guess? That's right, Google Maps and other Google services. I think you can probably guess a few others. Twitter, Foursquare, and then there's a bunch of services that exceed kind of those standard parameters that apps demand and somewhat less, clear and obvious to various people. For example, if you need to detect spam from submissions, you might be going to a Kismet. If you need to do spelling check, there's another service that provides that. And the list goes on. Geolocation. Perhaps you need to figure out where someone is within a building. You can do that now. Walmart, I just heard, came out with a geolocation service that works to help shoppers around their stores. And so there's a million, and the services behind that have mapped out the Bluetooth and wireless networks inside structures. So there's a million different services that your app can take advantage of. Summarize some of the key factors that tend to make apps more expensive. Custom UI. I have a brilliant game on my iPhone which uses a lot of 3D physics and all sorts of amazing graphics and such, so that wasn't very cheap to put up. Non-trivial architecture. Even on a native device, you may be getting into extensive architecture on the device. For example, if you need to merge a database like SQLite, and you need to do interesting stuff with not just geolocation, but also the gyros and things like that, you're starting to get into special expense. And then every time you're using an engine that doesn't handle everything, particularly the physics engines, and you have to do some special stuff, of course, it costs more. No one needs to be reminded that security is increasingly a big deal, and testing and your app and armoring it against intrusion is increasingly a challenge. On and on. Scalability is a huge issue, and I'm going to get to the scalability issue with a picture. So what you're looking at is from the Instagram engineering blog. A lot of the, because it's an open world and there's tons of open source and people kind of live with the spirit of that, a lot of the engineering teams are actually describing their backends and their infrastructure. And this is Instagram's, as of this year sometime when they described it, for you software architects out there, I think this is called the shared nothing architecture, which basically translates to this won't break because you can do failover very easily. You can do all sorts of rebalancing of your system. If you just bear with me for a second, because I think it's fascinating, I just want to describe what your little Instagram app, which probably wasn't that expensive, I don't know for sure, but it certainly wasn't as much as everything behind it, how much this all costs to do, and how much what's involved. So they're using Amazon Web Services, which is a very common way to go now. There's a few others. First, you balance the load of the apps requesting service from the back end, and then that's through the Amazon network, and you also have to do DNS resolution through what's called Route 53, an Amazon service. And then you use Nginx to push your requests out to various instances that you're running. And there's an API in Amazon and Rackspace and so forth that'll increase your instances or decrease them depending upon demand. They're using Python on the back end. They're using an app framework called Django to implement their Python code. And then they're using a bunch of special purpose servers. They're using Apache Solr to do GeoSearch on, when you take that picture, where are you? So that's Apache Solr doing that work. They're using Gunicorn as their WSGI server, which is a standard piece of most apps. Memcached, so they don't have to overload their servers with standard requests and standard content. They just cache a lot of it through Memcache. And then Redis, who some of you may recognize as a key store server to access the photos and such. And then just so on and on and on and on. And most of these things are open source. The vast majority of this is open source, except for, of course, Amazon and Amazon S3, which is providing the content delivery network. So this is expensive. This is very expensive. This was, as I mentioned, I think it was 500,000. What was the number? Let's go back to the front and find that out for a second. 5,000 hours. 5,000 hours. Now, not everyone does this. I know, for example, that Stack Overflow, at the last check-in, Stack Overflow was running things on just a few boxes in Manhattan, just a few. They're taking a big iron approach rather than this shared nothing approach, which relies on vast numbers of instances that are geographically distributed. Instagram has a lot of users in Japan and elsewhere. Stack Overflow is using basically big boxes. Now, looking at the whole app development framework itself, what is involved in developing apps? And those of you who've used a beautiful iPhone app, this slide almost doesn't need to be described to you, because it's obvious that you're in a world, at least on the commercial side, the retail side, I should say, that resembles more of a media event than it does software programming. I mean, you obviously have a major software component to it, but just like in media, you have all those people actually doing the movie or the content, and then you have to follow up with all sorts of other things that bear no resemblance, which is a much bigger share of the project. But that's the bottom line here. It's a much bigger share of a given app project to do all the non-coding work. So how easily can you get into app development? The truth is that a good programmer, a good software engineer, I should say, in the United States, I mentioned that number before, about $125 an hour, that's a high number. There's a significant learning curve to doing native apps. If you're on the Android, you're working in Eclipse, and you're working Xcode on the Mac framework or the iOS framework. These come with significant amounts of investment in learning, and so native apps are not cheap to build. This is the difference heretofore, I should say, because I'll describe how things are changing. This was done by, I think, Vision Mobile and Software Developer Economics, which is borrowed from them under Creative Commons license. This was a survey they did that showed the relative costs. And you can see here that among the developers surveyed, iOS tends to cost the most. Now, take this with a grain of salt. The BlackBerry didn't have the capabilities until the recent release of iOS. Android used Java for a lot of the programming, whereas you're using Objective-C for iOS, and the learning curves were just steeper. People didn't know how to program it as easily. Windows Phone, take with a grain of salt, because there probably weren't many data points for that. But these were the relative differences. Of course, things are changing. For example, if you want to develop a game, you don't necessarily have to do that natively. Here's an example. Here are three of, I would say, the most referenced game development tools. If you've been around for a while, you've heard of an authoring tool. The promise, the holy grail of authoring tools has been something people have discussed for a while. And I would say that they have come a long way, to the extent that they're actually a reality for many types of work. Game Salad, Stencil, Game Maker are authoring tools that let you build a game, I think, without ever touching code. I think you are able to, in some of these, actually touch code if you'd like, but you don't have to. And so we've really arrived in many ways at app development that doesn't have to engage the developer in native coding. And it's just going to get better or easier, depending upon your perspective, or cheaper. This is a patent that Apple filed. What is the date on this? 2011. Apple filed for what promises to be probably an even more versatile, and that's the key word, versatile authoring tool. I swiped some of the pages from that patent application. It's actually, I think, 71 pages long. And you can see some of the key details in these pages, how you can use this authoring tool that they proposed. I don't know the difference between this and the ones that have come before in terms of prior art, but apparently it's unique in how in this authoring tool you can build very versatile types of applications. It's in Apple's interest to promote this. They want more available, ever more available from their store, because they make money selling these things. They don't make money from developers necessarily, and so they want more apps. And if it's cheaper for people to develop apps, it's good for them. So this is in their interest, and it's in all the device and marketplace interests. Now, moving over, I mentioned native app development, but the truth is that non-native cross-platform app development is also very much evolving. These are probably three of the leading third-party SDKs that enable cross-platform development. Titanium, Accelerator, Titanium, jQuery, and PhoneGap permit developers, to build apps that run on generally all three of the major platforms. And BlackBerry permits you to run, with this latest version, they have a kit for moving Android apps to their platform. They take skills that developers already have, and they let those developers reuse those skills, apply those skills in combination with libraries that are specialized for the devices, and build apps that run to the user's eye, basically natively on those apps. Some of the difference is that a cross-platform solution may run a little slower. It depends upon what you're building, but there's tremendous promise here, and I know at least there's many examples. If you have LinkedIn, that's running a cross-platform solution, HTML5. If you're an enterprise, and I know a lot of people on the line now are representing larger companies, there seems to be a different solution evolving in the ecosystem of development, and these are called mobile enterprise application platforms. Some of the leaders are people you know very well. Motorola Mobility, SAP, and IBM are among them. But also you have Kony, Verivo, and Webelo. They're providing app development environments that enable enterprises to develop apps that sit well within their existing investment. There's tons and tons of legacy that sit in the IT stack, and that needs to be accessed, and integrity and all sorts of other issues need to be kept up. And that's what the function of these alternate approaches are. In fact, there's a relationship between these and other app development frameworks. There's a tremendous number of relationships. For example, WorkLight takes advantage of PhoneGap, which I introduced on the previous page. And as you research and decide on the approach you want to take, you can see how these things are all related. You know, on this previous slide up here, I'm just going to go back for a second. I mentioned only authoring tools for games, but it's a bit unfair. There are many other authoring tools for specialized purposes. For example, if you've got a band, and if you have a band out there, you can use Mobile Roadie. Mobile Roadie is an app development framework authoring tool for bands. If you have a media property or perhaps content specific, you can use Radwire. There's tons of specific approaches that you can take. And if you want to develop an app, but you don't want to develop it yourself, you can just download an app to actually suggest an app, and mobile will take care of it for you and give you 25% of the profit. So there's many ways you can go about developing an app these days, depending upon your business model and your availability for programmers and your environment. I'm going to move up again. I mentioned that these cross-platform approaches are being aided by a certain set of technologies, and the leading technologies I put up here. I think most of you are familiar with nearly all of these, and the reality is quite fantastic. You'll use CSS3 and HTML5 for your layout, and then your logic will be enabled using JavaScript. WebKit is providing a basic set of components that are being implemented on all the major operating systems, iOS and Android, and that's permitting easy access to core functionality of the device. These technologies, I think, are likely to make most future app development cross-platform because of how good they are and also how accessible they are to the large population of current web developers. Time for an infographic. Another acknowledgement, this was produced by Kinvey, which is a back-end as a service provider, and this is an infographic showing basically what the steps are to developing an app. You know, where do I start? And this is not everyone's process, but it's a good representation of what the general process is. So when you start over here, that's data storage. You first, as many people do, think in terms of data. I would argue that not everyone thinks this way, so it isn't necessarily the start. User management, server-side logic, data integration, push, and there's many, many ways of doing each step of these. There are application providers, for example, Flurry provides a very fine, and there are many competitors to Flurry, I should say, means of doing many of these steps, versioning, caching, wireframing. So they do here UI design very late in the architecture process. Other people would believe in doing the UI first and doing user performance and other issues first, and then pushing out the architecture. But that's up to all of you and the way you're used to doing business. So I wouldn't be a good person to be talking about this if I wasn't developing my own app. And I'm going to use this as an example. We are developing TourTrack with a team at RIT. TourTrack is a tool which will permit athletic events to monitor where people are and report that back for mapping and analytics. It's on the Android device, and it is first being rolled out to the Fibro Bike Tour with its 30,000 riders in May. It will sit at the Joint Operations Center, and people will be able to see at a glance how the ride is progressing. So it's a pretty cool little app that we're developing, and I thought it would be a nice little demonstration of how you might estimate one of these things. There's only just a few slides devoted to this, so any questions you might have, we'll cover them later. The basic architecture is this. The app uses geolocation to send back a periodic signal to a data collection server. That server is then going to send that information immediately to storage in MySQL. And then various algorithms will pre-process and batch that information so that it's called up, it's callable at will on an analytics platform that we're building on the back end, which is using OpenStreetMaps. And it will be a slippy map so that people can actually investigate the map, zoom in, zoom out, etc. If you look at that project in CRSIM, let me start off this screen by saying something I said much earlier, which is that the question of how you develop an app and how much do apps cost is as diverse as the question of how you develop any sort of software. And this is a great example of that. If you see the work breakdown structure for TourTrack, there may be pieces of this that I could call mobile, but there's lots that I wouldn't call mobile. The Android app is the mobile portion. The Android app is perhaps the lightest part of this work, or it's certainly not the main part of it. The data collection server is one of the bigger pieces, and we had to write code for that. We also have to worry about potentially several thousand people sending information back to us. And so in addition to algorithms that deconflict that, we also wanted to make sure as events get larger and more people send information back, we balance that, so we use HAProxy for that. And then we needed to integrate with Django. We're building everything in Python, so there's a little entry in 1, 2, 3 of the work breakdown structure for our application framework. Then on the analytics portion, we, as I mentioned in the previous slide, do a little bit of batch pre-processing basically batch. I won't go into details exactly how it works, but we do some pre-processing on that stored information sent back from the devices. We put that in here as a piece of code that we're going to model. And then the mapping code itself, there's glue basically that controls the interaction with OpenLayers. And OpenLayers is the front end for OpenStreetMaps. So we had to build that mapping code. And then we had to do this COTS element, some integration with OpenLayers. And this is the project in a nutshell. 3 major work breakdown elements reflecting the 3 major pieces of the architecture. One piece, which is the Android app, and I might say we're we're extensively relying on the Android library. There's a bit tying it together, but a lot of this is basically Android library. And then the DCS 1.2, or data collection server, where we've got a little bit of code tying together, again, a lot of off-the-shelf. And then the analytics. Again, there's off-the-shelf riddled throughout the project, and any project these days. Well, that, in a nutshell, is my exploration through app development. I'll just summarize this with a few major points. I believe that apps are generally becoming cheaper. Despite that horrific, or some would say fabulous slide that I showed you about Instagram, back-end as a service management is becoming very, very good. And I would argue that much more of the load balancing and instance management and DNS resolution and software raids and content delivery and caching and all the other stuff is being handled pretty much automatically. Unless you have very specialized needs, you probably can rely on an off-the-shelf solution. The second summary is that apps, which ties into the excuse me, first really is you're going to get much more expensive much more quickly if you have to rely on back-end. I mean, even if it's being handled by an off-the-shelf solution, I didn't say they were free. There's some significant costs that ramping up incurs very quickly. The ecosystem has evolved throughout the stack. I couldn't show you a certain slide which can't be licensed, but there's a wonderful, you can navigate over to Kinvey if you'd like to see it, K-N-V-Y. There's a wonderful slide that shows the evolving infrastructure. And basically, you have a continuum from the platform manufacturers, the Samsungs and HTCs and Apples of the world. You have a continuum going all the way back to those providing not just the, well, first of all, you have the IDEs below that, the phone gaps, and the other developers, development environments. Then you go all the way down the stack, and you have the backbone providers, the Verizons, and the others who provide the actual backbone of the Internet. And there's migration up and down that stack as the players jostle for their position in an ever-evolving ecosystem of app development. And indeed, app development is really a misnomer, because what we are developing is a service-oriented architecture that is becoming ever greater in its provision of off-the-shelf services for use by other applications. So even if you're not developing apps, the impact of app development and the number of published APIs that are increasing, which are increasing constantly, may have some bearing on work that you're doing in other respects. And my final note here is that it didn't take me much work to convert my new and dandy Android app project into something that I could estimate in CRSM. It's something we're readily able to do. And we've been watching mobile development and watching other technologies, and you can handle this in CRSM. Well, in a nutshell, that's it. And I hope you had as much fun listening to my exploration of this brave new world as I have had providing you with all the information. I'm opening up for questions.